so this is our second lesson in this particular course. We started inverse functions on Tuesday evening. So this isn't going to be our second lesson on, well, not functions, but on inverse functions. We will cover functions as well. Typically speaking, it's not something that is taught again in matric. It's something that's taught in grade 11, and you are expected to know that from matric. But we'll be doing lots of revision of functions before we actually get to the June exams, and certainly before we get to trials and finals. I've also got a question on functions to do maybe later in this lesson. We'll just see how things go. If we finish inverses of one-to-one sooner, then we can go and have a look at the question that I've got. All right, so that being said, let's just jump straight into this. The first thing that we're going to talk about when it comes to inverses are inverses of one-to-one functions. This is a very good place for us to start beginning to understand what an inverse is, how we write the notation, how we would sketch something, etc., etc. Typically speaking, however, when it comes to exams and control tests and those sorts of things, they would probably ask you questions about the inverse of a parabola and about the inverse of the logarithmic function. Generally, linear functions are not tested in exams, but you know, look, there's always a first time. So, but yeah, we've got to start here and understand it with respect to a linear function and then take it from there. All right, so the first example that we're going to go through is the function f of x equals 2x minus 4, which we all realize by now is a linear function. We know this because it's in the form y equals mx plus c. Right, so for function notation, we are allowed to write y as a function of x, and that represents our outputs. 2x minus 4, x over here, this represents our inputs, right? And I'm pointing this out to you because when we're doing inverses, we are switching x and y around. All right, so let's just talk a little bit about that before we actually jump in and finish off this example. So when we are talking about an inverse is something that can be looked at in one of two ways, all right? So either you can consider it as switching x and y. So in other words, what was our output is now our input, and what was our input is now our output. Okay, so input and output switch round. So input and output switch. Or the second way that you could consider an inverse is as a reflection. And it is a reflection over the line. Whoopsie, I'm going to write over, not whoever that was. Over the line. Come on, silly pen. Over the line, y equals x. Okay, so it can be looked at in either of those two ways. So either we consider it as swapping x and y with one another, but it means exactly the same thing if we reflect our function over the line y equals x. Okay, do you remember from grade 10, grade 11, what the line y equals x looks like? So just to grab a set of axes here, let's just do that very quickly. All right, the line y equals x is a horizontal line with a gradient of 1. Okay, and it goes through the origin. All right, so like that, that would be the line. The purple one would be the line y equals x. Okay, so when we switch x and y with one another, y becomes x and x becomes y. That's why we can also look at it as a reflection over this line. So let's jump back to our linear function, f of x equals 2x minus 4. All right, so the rule that transforms the given values in the domain, so in other words, our x values, into values in the range, the y values, using the rule 2x minus 4. So all they're saying is that f is a rule that takes inputs and changes them into outputs according to the rule 2x minus 4, okay? The rule that reverses this process and transforms 3 back into 2 is called the inverse of the original function. So in other words, if we want to do an inverse, let's just move this back up here. We are going to interchange our x and y values. So this rule is obtained by interchanging x and y, okay, and then making y the subject of the formula. So how do we do that? Well, the first thing that we would do is we would write down our rule, f of x equals 2x minus 4. Then when I want to interchange x and y, I'm going to write f of x using y. So in other words, this is y equals 2x minus 4. Now I'm going to interchange them. So in other words, I'm going to put x where y was, and I'm going to put y where x was. And now I need to make y the subject of the formula as it says here. Okay, and then making y the subject of the formula. That means moving negative 4 back over to the other side, so that's there with x. So it will become x plus 4 equals 2y. And now since y needs to be the subject of the formula, I need to divide through by 2. So I'm going to divide this by 2, this by 2, and this by 2. That means that I end up with a rule, y equals x over 2, which I can write as half x, plus 4 divided by 2 would give me 2. So because this inverse is a function, I'm allowed to use it writing functional notation. So my functional notation is the same f, and then I use a little -1 like that. Okay, it doesn't mean the same thing as when we're working with exponents. Right, so if I am working with exponents and I say 3 to the power of -1, this means that I have to invert and then change the sign of my fraction. It's not the same thing as that. Okay, so over here, this is just the notation that we use, the function notation that we use to show that it is an inverse. Okay, so that means that f minus 1 of x is the inverse of f of x. Okay, so the -1 is a symbol. It is not an exponent. All right, and now I'm allowed to continue writing this as 1 over 2x plus 2. All right, everybody happy with that? Are there any questions?
Please raise your hand, or you can just indicate if y'all understand on the chats. Thumbs up, thumbs down, take screenshots. Oh, Dave is there.
Yeah, sure. Go for it. Go for it, Dave. Ask a question if you need to. You're
welcome. Hi. I'm not
just one second. I'm gonna unmute. I muted Mohale, so Dave, you can go ahead. Please remember, you need to raise your hand and then wait for your cue, because Teacher Lee will definitely call your name. Then you can ask. Okay. Thank you, my people.
Okay, go for it, Dave. Although you sound like a girl and not a boy.
Ma'am, my question is, if I were to write it as x plus 4 over 2, just over 2, instead of x divided by 2 plus 4 divided by 2, would that be incorrect?
So, sorry, how did you say it if you wrote it as x plus 4 over 2? Absolutely fine. No problem. Okay, so you'll see that's the way in which they choose to do it down here. I haven't gone down there, but yeah, that's exactly what they choose to do over there. So you don't actually have to do it like that. And the other thing you could also do if you wanted to is you could write the rule as x over 2 plus 2, and that would also be fine. Okay, so yeah, not a problem with that at all. Okay, Unam?
Sorry, ma'am, 4. What happened to, you said most the rule y equal to 2, no? So why is y equal to a half x plus 2? Like, I don't understand that concept now.
Okay, so in other words, what you've done here, Unam, is that you have divided through by 2 because you can't have 2y being the subject of the formula. Okay, so 2 was the coefficient of x in the original function. So 2 is now the coefficient of x once we interchange x and y around like we did over here. Then we've got to go through this process of making y the subject to the formula. So it can't be 2y equals, it has to be 1y equals. And that's why we have to divide through by 2. Okay, so I'm dividing x by 2 and I'm dividing 4 by 2. That's how come I end up with half x or x over 2 plus 2.
Ma'am, 4 divided by 2 is 2, ma'am.
Yeah, so you would divide by whatever the coefficient was. So for example, let me just go down here and just do another quick example for you. Let's say I had an original function f of x and it was equal to 3x minus 1. Please mute if you're not speaking to me. Thank you very much. And now I want to do the inverse of this. All right, so I've got my y equals 3x minus 1. I interchange x and y, so x equals 3y minus 1. Now I'm not going to divide by 2. Now I'm going to divide by 3 after taking the 1 over to the other side. So in other words, here I'm going to end up with 3y. I'm going to have x plus 1. And now I'm going to divide both sides by 3. So now you'd end up with y equals x plus 1 over 3. Okay, so you have to divide by whatever your coefficient is. Okay, Onam? All right. I think there was one more question. Omokolo?
Good day, ma'am. Sorry, I'm late. So,
Beg your pardon?
Sorry, I'm late. So
Oh, okay, that's fine, no problem. Okay, glad that you're here with us. Okay, so let's just see what you guys were saying in the chats. Yes, Amatli, we're doing the inverse of functions. Okay, and we're starting off with the linear function. All right, so the next thing that they want us to be able to do after we have calculated the equation of the inverse of the function is they want us to be able to sketch these, right? So that's really, really important, okay? We're going to try and draw these. So if you recall from up above, we had two functions. The first function that we had was the line y equals 2x minus 4. Okay, the other function that we've got now is y is equal to half x, or if I want to write it like this, x plus 4 over 2. I want to sketch those. So in order to sketch a straight line on a Cartesian plane, what information do I need? What do I need to be able to draw a straight line? You can pop it into the chat or raise a hand and then you may speak. So Sindiswa, you may talk.
Ma'am, you need to find your intercepts.
Absolutely, fantastic, well done. Okay, so we need to find our x and our y intercepts. Okay, so for our x intercepts, we're going to let y be equal to 0. For our y-intercept, we're going to let x be equal to 0. So in other words, all we need are 2 points. We just need 2 points in order to be able to draw a straight line. Okay, so our next job now is to go and find the x and y intercepts of these lines. As far as finding our y-intercept is concerned, what does this value that I'm highlighting in yellow, what does it tell me about this particular function? What does the minus 4 tell me about the function? Amahle, go for it.
Ma'am, it starts at the point -4.
Absolutely. So, okay, so when you say it starts at the point, does that mean that it doesn't, that there's no numbers that are smaller than -4? That's it. Okay, that's in Nhlanhla, that's exactly what I was looking for. Okay, it is the y-intercept. So remember, when a linear function is written in the form y equals mx plus c, this c value over here is your y-intercept. Okay, so in other words, the y-intercept of the line y equals 2x minus 4, its y-intercept, or the coordinates that its y-intercept would be that 0 and -4. Okay, 2, so this number over here, which would be the m, what does that tell me about my function? What does the letter m represent in my function? Yes, Samkelo.
Ma'am, it represents your gradient.
Absolutely. Brilliant. Okay, so it represents your gradient. Okay, so the gradient of the line is 2. Okay, brilliant. In this case over here, same story. If we split it apart like I had done earlier and write it as y equals half x plus 2, it's also very easy for us to see what the y-intercept is. Right, so again, it's this value that I'm highlighting in yellow. That is our y-intercept. So straight away, I can see that the y-intercept of my inverse is going to be at 0 and 2, like so. Right, so I don't need to calculate my y-intercepts when my function is the form y equals mx plus c, but I still need to calculate my x-intercepts. So for my x-intercepts, I have to make y equal to 0. So I'm going to take 0 and substitute it in the place of y, and then I'm going to write 2x minus 4. I'm going to take the 4 over to the other side, and I'm going to divide both sides by 2. And then that means that x is going to be equal to 2. So my x-intercept for this function will be 2 and 0. Okay. Similarly, for the other function, right, I'm going to make y equal to 0. So now I'm going to say 0 equals x plus 4 over 2, or if I work with half x plus 2, it makes no difference. The first thing that I want to do is multiply both sides by 2. So that means that we'll end up with x plus 4 once I've multiplied both sides by 2. And then I'm going to take the 4 over to the other side. So it becomes -4 on the other side. And that means that the coordinates of that intercept are -4 and 0. So now if we go and have a look, all right, this line over here, okay, let's leave this in yellow. There's its y-intercept, there's its x-intercept. Okay, so the x-intercept is this point over here, the y-intercept is that point over there. I would get a ruler after plotting those 2 points, and then I would connect them. So there is the graph of f, my original function. Okay, so sorry, excuse my skew yellow line, just draw it all the way up to the top. Okay, so there is my graph of y equals 2x minus 4. And I would do exactly the same thing with the other function. Let's just get rid of the yellow and we'll write it a different color. Let's choose green. Okay, so now my graph y equals half x plus 2. There is my y-intercept. And down here, this was my x-intercept. So my x-intercept is at -4. My y-intercept is at 2. Going to grab a ruler, connect my 2 lines like that. And again, I'm going to label my line. All right. What are some of the other things that I need to show when I've been asked to sketch something like this? Well, we need to show the line y equals x. So that's here, that's this dotted line over there. There's your line y equals x. Okay, and again, they have labeled it. Right, now there's something that I want to point out to you guys, but before I do that, I just see there's a few things in the chat. I just want to go and have a look. Okay, so brighter color, gradient, yes, that's gradient, M is gradient, yes, 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 perfect, 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 perfect. Okay, so have I highlighted, are the colors bright enough? Can you see that? Is it okay? Is the pink and the yellow and the green coming through? Cool. All right. I'm so glad. Okay. So the other thing that I wanted to point out to you, all right, is that what was Y has become X and what was X has become Y. Remember, that's what happens when we reflect over the line Y equals X. So look here very carefully, okay? Here was the Y-intercept at 0 and 2. It is now your x-intercept of your inverse function at 2 and 0. Can you see how x and y have changed round? Okay, what was the y-intercept is now the x-intercepts, and the coordinates have switched. Okay, and exactly the same thing will happen with the x-intercept and the y-intercept. What was the x-intercept on our original function is now the y-intercept on our inverse. Again, can you see how x and y have switched around? Okay, is that clear to everybody? Is everybody happy up to this point? Thumbs up, thumbs down. Is it making sense? Good. Oh, lovely. Thanks, guys. That's great. Brilliant. I'm glad everybody's oh, good. I'm glad, Faheen. Good. Okay. So the other thing that they might ask you to do, Matrix, is they might ask you to solve the coordinates at the point of intersection. So because this point of intersection, so in other words, the point of intersection that I'm referring to is this one over here where the purple arrow is. Right. So you could use any two, I beg your pardon, of the 3 lines that intersect at that point. But let's say you decided to use the 2 functions, right? Because they are equal to one another at this point, we would make 2x minus 4 equal to x plus 4 over 2. And then we would need to solve for the x coordinate. So because this is a linear equation, I'm going to multiply each term in the equation by 2 in order to get rid of the denominator. So this would become 4x, this would become minus 8, and this would become x plus 4. Collect x's one side, numbers the other side. I now have 3x is equal to 12. I'm going to divide both sides by 3, and x would be equal to 4. Okay, and that's why they've got that 4 over there that I've just put a little purple circle around. That's where that comes from. Now, in order to calculate the corresponding y coordinate, I can sub it into any one. I could sub it into the yellow, the pink, or the green. Okay, and I'm going to get the same answer of y being equal to 4. So let's say I decide to go with y is equal to 2 times 4. I'm subbing into the yellow one now. Minus 4. Can you see? Whoopsie, sorry. I went over to the side instead of underneath. Y would be equal to 4 as well. Okay, so therefore the coordinates at the point of intersection of these 2 lines would be 4 and 4. Luam, you are saying, could you also say 2x minus 4 is equal to x? Yes. So 2x minus 4 is equal to x, absolutely. So now look what happens. That's even easier, isn't it, Luam? Okay, when I take my x over to the other side, I'd get that. Taking the negative 4 over to the right, I'd get that. And you can see here, you'd end up with x being equal to 4. Okay, so you can use any two of the three that are there and you will get exactly the same answers. So you could use the pink and the yellow, or you could use the pink and the green, or you could use the yellow and the green like I had done. Okay, and you would see you would get exactly the same answers. If you use the pink one, it's going to be much easier, Luam, just like you said over here. Okay, so that would be the shortest way of being able to do it. Okay. All right, and then again, when you draw your functions, all right, it's important for you to label the important points. Don't worry about putting numbers on your axes, okay? And in fact, what you should do is sketch your graphs first and then worry about putting, then labeling the intercepts. Okay, that's much, much easier rather than trying to make everything fit afterwards, okay? All right, brilliant. So now that we've said all of that, I've discussed that with you. Okay, just a few points to note. So the function f of x equals 2x minus 4 is a one-to-one linear function. Its inverse is also a one-to-one function, and the two graphs are symmetrical to each other about the line y equals x. And certainly when we look at it like that, we can see that they are symmetrical to one another. Okay, so the yellow line has been reflected over the pink line to give the green one. Okay, so they are mirror images of one another over the line y equals x. Okay, yeah, take screenshots, always a good idea. I'm going to move down now, and I'm going to give you guys an opportunity to try a couple of questions. Okay, so this is for you. So for each function, I want you to determine the inverse in the form f to the minus 1x equals. Then you're going to draw a neat sketch of both functions on the same set of axes, just like I showed you. All right, make sure you also draw in the line of symmetry and that you label it. And then I want you to determine the coordinates of the point of intersection of both graphs, and you're going to put that on as well. So it's exactly the same as what it is that I've just showed you how to do. If you are a fast finisher, yes, I'll move up, Siam Tanda. Do you want me to go here, Siam Tanda? Are we all good? No problem. I'm going to go back down again now. If you are a fast finisher, then try both. All right, so I'm going to give you, gosh, it's going to take a little bit of time, but let's say about 6, 7, maybe even up to 10 minutes. Let's just see how you guys go. All right, if there are any questions, I'll take them now. Otherwise,
I think Mary's up there.
yeah, I see
Sorry.
Mary's got her hand up. No, absolutely. Thanks for pointing it out. Otherwise, just get started and don't worry about me if I'm talking in the background, just trying to help other people. Okay, Mary, go for it and ask your question.
It's okay. I will help Mary. I think Mary is not connected to audio.
Oh, yes, I think you're right. I can see Mary's not connected to audio. Okay, all right. Oh, yes, she says she can't hear any voices. All right. Yes, Tabelo, it's B and C. So B and E, sorry. So you're doing 1, 2, 3, and 4 for B and for E if you can. Okay. Is that better?
Yes, no, on my screen, it's absolutely okay.
Oh, okay.
So it should be okay to most of us.
All right. Is it better like that? Actually, I've never considered doing it this way.
Yes, it's better, way better.
Oh, is it? Okay, you can see more. Okay, all right, then let's do this then. Wow, that's fantastic, Nellen. Well done. Did you do B? Excellent. Okay, so you've done B, try E. Okay, good job. Well done, Amahle. So try E as well, okay. Good, Siam Tanda. Nice title. So we'll mark it now. You're also on E. Good, Faheen. Well done. Lovely. Okay, good. Good, Mamelo. Good, Hamokilani. Nice one there. Yes, please. Okay, so you're going to sketch the graphs of both. And the line of symmetry. Okay, so once you've done part one and you've got the equations of the inverses, okay, that's perfect. Well done. Now you can worry about sketching them on the axes, putting in the line of symmetry, and then calculating the coordinates at the point of intersection. Okay, good. Cool, Amahle. Have you sketched them as well, Amahle? And your line of symmetry and worked out your coordinates? Good stuff, well done. All right, so I'll just wait another couple of minutes or so, just give most people a chance to finish, and then we can look at the answers and move on. Go Prosper. Good, Chantal. Well done, Daneo. Okay, so hopefully most of us are finished by now. Yes, okay, I see lots of things coming through saying done, 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 done with both. Cool, all right, Mary, you also done. Nice, Tina. Okay, so good, Mamelo, you done. Samkelo, you done. Zahufatso, you done. Amokilani, you are done. Good stuff. All right, so let's go down and go and have a look at the answers. All right, so as far as the first one was concerned, this is what we should have. Okay, let's just grab that, put that over there and just make that a little bit bigger. Okay, so this is question B. All right, so there's the equation of the inverse. Of course, if you wanted to write that as 1 over 3x plus 2, or if you wanted to write it as x over 3 plus 2, that's absolutely fine, not a problem at all. So the original function, let's just highlight that in a different color. All right, I just need to get my... Sorry, I'm just looking if I can move my bar here. Doesn't look like it. Okay, sorry, unfortunately, I need to go back to that in order to be able to do this. Sorry, guys, I know it's better when it's bigger, but we can go back. Lusanda, I'm going to take your question now. Just give me 1 second. So I'm just highlighting that in yellow, okay, so that you guys can see which line it is. It's this line over here. Okay, so that's our original function. And then our inverse function, I'm going to highlight in green. So that's this one over here. It looks like that. There's our inverse. Here is our line y equals x. I'm going to put that in pink again. Right, there we go. And there are our x and y intercepts. Okay, so Lusanda, you had a question. Would you like to ask? You're welcome to unmute.
Hi, ma'am.
Hello, how are you?
I'm good. How are you, ma'am?
I'm fine, thank you.
Ma'am, is it fine if I wrote the inverse of the first graph as 1 over 3x plus 3?
Not 3, okay, because the reason why it's not 3 is because 6 divided by 3 is not 3, it's 2. Okay, so if you want to write it like this, Okay, because essentially what you're doing is you're taking x and you're dividing x by 3, and then you're taking 6 and you're dividing 6 by 3. Okay, so that would give you x over 3 or 1 over 3x. It's the same thing. 6 divided by 3, that would be 2. Okay, and then you can see here that 2 over there is this 2 over here. Okay, on your inverse.
Thank you,
Okay,
ma'am.
Lucinda. All right, no problem. Okay, so Mary, you've also got a question. You're welcome to unmute and speak if you want to. For the rest of you, there are the coordinates at the point of intersection. Did we get that right? So Mary, if you want to unmute, you're more than welcome, or you can put your answer in the chat. Can we say a thumbs up for question B? Did we get everything correct?
Hello, ma'am.
Hello, Mary.
How are you?
I'm fine. How are you?
I'm also fine. I
Good.
wanted to ask about the question of B, right?
Mm-hmm.
So that I can simplify further about this function of reflection.
Yes.
Okay. From there,
What?
I can have 1 over 3x plus 2.
Correct. Correct. So if you want to write it like this as 1
Yeah.
over 3x plus 2, there's nothing wrong with that.
Okay, thank you.
Okay. All right. Perfect. No problem.
Good.
Good stuff. Okay. Let's just have a look at your responses. Yes. Okay. So a lot of you are putting thumbs up. That's wonderful. Well done. Okay. So we're going to go and have a look at the answer to E now. Sindiswa, do you want to ask a question before I move on?
Yes, ma'am. Can I ask, how did you get the coordinates of the intersection?
Sure, that's fine. Let me just do that calculation very quickly and then I'll move on. Which 2 equations did you use, Sindiswa?
I used y equals to 1 over 3x plus 2 and y equals to 3x minus 6.
Okay, that's fine. So I'm just going to use the same ones that you did, just so that we can, what I'm doing is the same thing as you. Okay, so the first thing that I would do if I was solving this equation is I want to get rid of my fractions. So I'm going to multiply every single term in my equation by 3 to get rid of the 1 over 3. So that's going to leave me with 1x plus 6 equals 9x minus 18. I've times everything by 3. All right. Now I'm going to put x's one side and numbers the other side. So if I leave my 9x here, I'm going to bring my other x over. And then I'm going to leave 6 here and I'm going to take my 18 over to the other side. So 9x minus x is 8x and 6 and 18 leaves me with 24. And now I'm going to divide both sides by 8, which means that x would be equal to 3. Okay, and then I think this equation over here is the easier one to use to solve for y, but you could use both, it doesn't matter. So now I'm going to say y equals 3, then x is equal to 3. So I'm going to I wrote x instead of 3. Sub in my 3 for my x, and then I need to take away 6. So that leaves me with 9 minus 6, and that's where I would get the 3 from. Okay, so that's how I got my coordinates, 3 and 3. Okay. Samkelo, you've got a question?
Yes, ma'am. Ma'am, so for my answer, like, I don't know what I did wrong, but like I struggled to get the y equals. So instead I got 1 over 3y plus 2 is equals to 8.
Okay, so let me just write that down. So you got, just say that again, please, Samkelo.
1 over 3y plus 2 is equals to 8.
Okay, so what you did here is that you just didn't switch your X and Y around. Okay, so in other words, when you were doing your inverse, go through, let me take you through the process again. So you've got f of x, and that was equal to 3x minus 6, right? So first of all, you're going to write that. You're going to write f of x as y. And now you're going to do the inverse. So now you're going to switch them around. So you're going to say x is equal to 3y minus 6. All right. And now you're going to put the 6 together with the x. And then you want to divide everything by 3. Okay. So now here you're going to divide that by 3 and that by 3 and that by 3. Or if you want to, you can just leave the y on its own, x plus 6 over 3 like that. Okay, so that's why you should have ended up with a 1 over 3x plus 2. Okay, so in the end, what happened is that your x and your y were just in the wrong place.
Okay, thank you, ma'am.
Okay, all right, no problem. I just see there are a couple of other hands up. Oh, not anymore. Okay, all right. So now let's go and have a look at the answer for the next one. Okay, here we go. This was question E. So I'm just going to put that into the middle of the page and make it a little bit bigger. All right, so now you guys can mark your work there as well.
Take screenshot.
Yeah, take screenshots. Okay, did I see another question or am I imagining things? Oh, no, there wasn't. Okay, so yes, take screenshots if you need to. Again, let me highlight things in color for you guys, just makes it a little bit easier. So here we had f of x and it was equal to negative 2x. All right, so let's highlight that in yellow. So our graph of f of x is going to be this graph over here. Okay, ignore this dot, it's supposed to be on the line. It's just not very well drawn. Okay, so there's our graph of f in yellow. Here is our inverse graph, the one in green. Okay, here is our line, y equals x. Okay, and yes, and again, if you so for this particular graph you would have needed another point in order to be able to sketch. Right, so I see in this case here they've used -1 and 2 and 2 and -1, but to be honest with you, you could actually use any point if you wanted. If you want me to explain that or show you how they got those values, then I'm obviously more than happy to do so. Okay, Amahle, I see you've got a question.
Ma'am,
Yes.
will the line y is equal to x always run through the third and the first quadrant?
Yes, it will. It will. Because what you're looking at, okay, in the beginning, trying to understand what y equals x is actually very difficult, all right? But then when we break it down, it's actually not so hard. What they mean is y equals 1x plus 0. So your y-intercept is 0. That's why it goes to the origin. And it has a gradient of 1. So the line y equals x, yes, it'll always go through the third and the first quadrants. If you have the line y equals negative x, because that line also exists, but we don't do any reflections over it in the trick, then what happens here, and let me draw it in a different color, just find something that will stand out. So maybe this pink over here, this line would go through quadrants 2 and 4. All right, so it would look something like this. That would be the line y equals minus x.
Okay.
Okay, but you don't have to worry about that in this section, thank goodness. Okay, there we go.
Okay,
all right.
Thank you so much.
Oh, pleasure.
Hello,
Any other
ma'am.
questions? Hello, Amukalani, how are you?
I'm good, thanks, ma'am. So, ma'am, how do we get the points on the line of symmetry,
Okay, you don't have to worry about the points on the line of symmetry. Okay, you can always just draw in the line y equals x as a, because essentially what the line y equals x is doing is it's cutting the first quadrant in half and it's cutting the third quadrant in half. Okay, so in other words, let me just show you, let's go past this one, right? So we've got y equals minus 2x, which is our graph of f, and then our inverse, we've got the graph y equals minus 1 over 2x. All right, so let me grab and I'm going to demonstrate now exactly how it is that you would do this, right? Because you guys are asking. Obviously, I don't. More than happy to do this. So there's my set of axes, right? Here is my y-axis. Here is my x-axis. So what I would do if I was you guys is I would just grab a ruler, all right, and draw your line. Let's just make sure they're giving us this. And you're basically just going to do this. Okay, so if I want to draw my line y equals x, that's all I'm going to do. So as long as it cuts your first quadrant in half and your third quadrant in half, and it goes through the origin, the actual gradient of the line is not that important. Okay, so it needs to look like that. Does that make sense to everybody? Okay, now the problem with sketching this particular graph, and that's why it's the more difficult one of the two, is because in order to draw a line, a straight line, you need to have 2 points. So when you do the x-intercept and the y-intercept for both, you end up with the origin, you end up with 0, don't you? Because for here, we can see that this line, that the value of c is 0, okay? So that means that the y-intercept is 0 and 0. And then if we go and we sub in and we say 0 is equal to minus 2x, and we solve for x, we also get x is equal to 0. So now it becomes difficult for us to draw this particular line. So what we need to do here is we need to use values. Now, it does not matter what values you choose to use. Okay, in the case of this graph over here, this one over here, they used -1 and 2, and then they drew the inverse of that, right? You can choose, let me just go back here, you can choose any values you want, right? So let's say you decide you are going to work with, because we know that the line goes through the third quadrant and the fourth quadrant. So let's say we decide that we're going to use the point, we're going to use -1 as our x. Right? Now we want to work out what our corresponding y is so that we've got a point that we can plot. So I would go and I would sub that in. So I would say y is equal to -2 times -1, and that's going to leave me with 2. So in other words, when x is equal to -1, y is equal to 2. All right. Or if you wanted to use, it would have to be a -x. Well, mind you, you could use a positive x, but then it would obviously be plotting somewhere down here. Let's say you decided to use an even smaller number. Let's say you wanted to use -3. You could do that. All right, so this is a table of values. So now if we wanted to work out what y would be, we would say y would be equal to -2 times -3. This would give us 6. So you can use 1 against 2 or -3 against 6, whichever coordinates you want. Okay, then here you would just have to go and plot that point. So let's say you're now going to go and plot the point -1 and 2. The easiest thing for you to do though, all right, is you know that it's got to go through that point. It's got to go through the origin. So now I'm going to do that. And then over here, I'm going to label that point over there as -1 and 2. Now, as far as the inverse is concerned, remember x and y have switched around. So what was your x is now your y, and what was your y is now your x. So if we're talking specifically about these numbers over here, when I want to draw that same point on the other graph, it's going to have switched around. So in other words, my x is now 2 and my y will be equal to -1. Okay, so can you see here how I have switched x and y around? Okay, what was x is now y, and what was y is now x. Let me label my graph. This is the graph of f. Okay, now I want to sketch my other graph. All right, so in other words, the one minus half x. So let's use a different color. I just suppose I can use the color that I've got. Here we go. And this line also needs to go through the origin, but it's got to go through the points 2 and -1. So where is 2 and -1 located? Okay, y is negative, x is positive, so this has to be a point in the 4th quadrant, doesn't it? Okay. The other thing that is important to note here is the difference in the gradients. Okay, so in other words, the gradient of the line -2 is steeper than the other line, right? So here my gradient needs to be shallower. So I'm going to put that line over there like that. Okay, so here is my graph of the inverse. And that point is now reflected to somewhere over here, all right, to the coordinates 2 and -1. Okay, so that's what you would do. That's what it would look like. Yes, Nolwazi. So with this particular graph, this one was a little bit more difficult because both of them go through the origin. That's why we had to use the table of values in this particular case. Okay. So whenever you are sketching a straight line, you can always use a table of values. It's easier to use the x and y intercepts, but in the case of this particular function and its inverse, the x and y intercepts didn't help us. That's why we used a little table of values to help us get some coordinates that we could use. Okay, does that answer that question? I hope so. So Mosama, I hope I've answered your question. Nolwazi, I hope I've answered your question. Oh my gosh, is that the time already? Goodness me.
Yes, I was trying to get your attention.
No, sorry. Okay, so Sharon, I've shown you. So there's one more question. Mosama, you said, why is the line y equals x going in the opposite direction? It's not going in the opposite direction. It's exactly the same. It's just purple now. If you have a look there, there's your line y equals x. It's going through quadrants 3 and 1. Here it's going through 3 and 1 as well. Okay. All right. And Nhlanhla, yes, you can unmute. And then I'm afraid I'm going to have to go. Go for it.
Afternoon, ma'am.
Afternoon.
Ma'am, I just wanted to ask, what if we didn't use any coordinates for the y-intercept? What if we left it at 0?
That's fine. The only thing is that, I mean, we are supposed to show some coordinates on the line. So that's why in this case over here, they used -1 and 2. We could have used any. All right. But I think it is important to at least have one pair of coordinates on the line. Okay.
Thank you, ma'am.
As long as it is the correct input and output, they would be absolutely fine with that. Okay.